surface chemistry total weightage for board exam ku 11 marks irukku. Out of 11, 3 1 mark questions. 3 1 mark questions, 1 3 mark question, then 1 5 mark question. Solid state combines with surface chemistry. Okay. So overall weightage pathina 3 1 mark question, then 1 3 mark question, 1 5 mark question, altogether 11 marks. Altogether 11 marks. Okay. So this is not in part 3. 5 mark mean in 10 mark la combination. Okay, combine with solid state with surface chemistry la varum. Okay. So 3 important irukadala ulla irundhu kuda kepanga, indirect kepanga maximum. So first, what is surface chemistry? Any idea about surface chemistry? Surface. Huh? We are going to study about surface. Okay. First, we are going to introduce one term here, adsorption. AD, adsorption. We have to know what is the difference between AB, absorption, and AD, adsorption. Any idea? What do you mean adsorption? What do you mean absorption? Absorption mean? Okay, it absorbs the water molecule. Very good. Just think about cotton. Think about cotton. Okay, just you are going to add water molecule. Now water enter the inside also. The interior particle also absorb the water molecule. That's called AB, absorption. What do you mean AD, adsorption? Very good. Just think about on a piece of wood or piece of stone. Okay, now we are going to add water. So piece will adsorb, no? AB. Okay, so the piece of wood or a stone absorb the water molecule only in the surrounding, in surface alone. That's called AD, adsorption. So adsorption is the surface phenomenon. Adsorption is the surface phenomenon. The first 5 mark question in this lesson, what is the difference between physical adsorption and chemical adsorption, otherwise called physisorption and chemisorption. Physical adsorption nothing but physisorption, chemical adsorption nothing but chemisorption. Okay, very important 5 mark question. First point, it is due to intermolecular van der Waals force. Van der Waals force is the very weakest force, isn't it? Intermolecular mean you know very well. Intermolecular mean between 2 different molecules. So physical adsorption mean it is due to intermolecular van der Waals force, but that is due to chemical bond formation. Chemical adsorption mean due to chemical bond formation. Here easily depends upon nature of gas. Easily liquefiable gases absorb very easily, but here more specific than physical adsorption. Heat of adsorption is very small. Heat of adsorption very large. Reversible reaction, irreversible reaction. It occurs very rapidly at low temperature. When at increase temperature, what will happen? It will decrease. It will increase in at low temperature. But when you are increase the temperature, what type of adsorption? Decreases. But here increases with increase in temperature. Increase of pressure, increase the adsorption. There is no change in the pressure. Forms multimolecular layer, forms unimolecular layer. That is a 1 mark question. Dash forms multimolecular layer. Physical adsorption forms multimolecular layer. Okay, you have to memorize all the points. Then factors affecting adsorption, very important 5 mark question. What are the factors going to affect that adsorption? Factors affecting adsorption. Factors affecting adsorption. Some points. First one is a temperature, pressure, temperature, pressure, nature of gas, nature of adsorbate. Okay, what are the factors going to affect adsorption? First one, temperature and pressure. How temperature and pressure going to affect the adsorption. Okay, adsorption takes place very normally mean whatever temperature very low temperature you need. Okay, adsorption takes place very fast mean temperature must be very low, pressure must be high pressure. Okay, so when adsorption takes place smoothly mean temperature must be very low, at low temperature adsorption takes place very fast, very same time whatever pressure at high pressure. Okay, so what is the condition, essential condition for adsorption takes place, temperature must be low, pressure will be high, that only given to you, effect of temperature and pressure. Then nature of gas, already I told you, easily liquefiable gases are adsorbed very easily, liquefiable gases are adsorbed very easily. Then nature of the adsorbent, the surface area of the adsorbent large mean it react very fast. Okay, so that depends upon the nature surface of the adsorbent. Okay, I will tell one story, no, the Pongal story. Remember the story? Huh? No. Okay, now we are going to give Pongal, sweet Pongal. Okay, ரெண்டு இதில் பாட்டில் பொங்கல் வைக்கிறோம், ஒரு பாட்டில் ஸ்வீட் இருக்குல்ல அந்த வெள்ளைக்கட்டி வெல்லம் பெரிய பீஸ் தூக்கி போட்டாச்சு, இன்னொரு பாட்டில் அதே வெள்ளத்தை பவுடர் பண்ணி உடச்சி பவுடர் பண்ணி போட்டாச்சு. இப்போ எதில் ஃபாஸ்ட் நம்ம பொங்கல் ரெடி ஆகும்? ஏன்? சீக்கிரமாக கரைஞ்சிரும். That means chemically this is a piece of chalk piece. Okay, it's a chalk piece. Just think about surface area. Okay, this is the surface area. Now I am going to break the chalk piece. What about surface area now? Increases or decreases or remains constant? Surface area of the chalk pieces increases or decreases or remains constant? Surface area decreases, increases. How it decrease? No, surface area increases because these two sides are newly created. Okay, initially there is no that page. Now how many pages are created newly? 2 pages. Again I am breaking the smaller into smaller particles. What will happen? Because new phases are creating, so their surface area increases. So when you are creating such a small particles mean what about surface area? Increases. Surface area keep on increases. Surface area increases mean what will happen? Adsorption takes place very easily. So that ஒரு இதில் வெள்ளக்கட்டி பெருசாக போட்டோம், இன்னொன்று என்ன பண்ணோம், பவுடர் பண்ணி போட்டதில் சர்ஃபேஸ் ஏரியா அதிகமானதால் இட் ரியாக்ட் வெரி ஃபாஸ்ட், ஈஸியாக கரைஞ்சி போச்சு, ஈஸியாக பொங்கல் ரெடி ஆச்சு. கிளியர்? ஸோ சர்ஃபேஸ் ஏரியா இன்க்ரீசஸ், ரியாக்ஷன் ரேட் ஆல்சோ இன்க்ரீசஸ். கிளியர்? ஸோ ஹியர் தி நேச்சர் ஆஃப் அட்சார்பன்ட் மீன் தி அட்சார்பன்ட் சர்ஃபேஸ் ஏரியா வெரி லார்ஜ் ஏரியா மீன் இட்ஸ் அப்சார்ப் வெரி ஈஸிலி. கிளியர்? இட்ஸ் a 5 mark question. Then catalysis. What is catalyst? Wrong. Catalyst is a substance just alter the speed of the reaction, maybe increase or maybe decrease or remains constant or destroy the activity of the catalyst also, not only increase, but commonly we will increase to commonly we are using the catalyst for what purpose? Increase the rate of the reaction. Okay, so catalyst is a substance just alter the speed of the reaction, that only correct word, just alter the speed of the reaction, maybe increase or decrease or remains constant. Clear? That only catalyst. Here the given potassium chlorate undergoes oxidation reaction, it gives potassium chloride and oxygen. Here MnO2 acts as the catalyst. Okay, so catalyst is a substance just alter the speed of the reaction. Clear? So in this reaction potassium chlorate converted into KCl and O2. Potassium chloride formula KClO3, it gives KCl plus O2. Just balance the equation. To 3 mean here 3 means 6 will come. So 2. So 2 potassium in 2. 2 Cl, 2 C. I think everything balanced. Here what is act as a catalyst? Here M1O2 act as the catalyst. M1 act as the catalyst. The next 5 mark question, general characteristics of catalytic reaction. General characteristics of catalytic reaction. Okay. Now what are the qualification? Okay, one substance going to act as the catalyst mean what are the qualification? What are the characteristics? That mean catalyst just alter the speed of the reaction, isn't it? So that catalyst not involving in the chemical reaction. So that the mass of the catalyst before the chemical reaction, after the chemical reaction must be same. That mean what? Catalyst not involving in the chemical reaction. Suppose catalyst involved in the chemical reaction mean reacted mean some other product will form. So catalyst not reacting with the reactant molecule. So that before the chemical reaction, after the chemical reaction, the mass of the catalyst must be the same. Then very small quantity of the catalyst is enough. Large neriya potana neriya fast nadakkum kedaiyadhu. Okay, quantity very small quantity is enough to do the work. Okay, then catalyst does not initiate the chemical reaction. Okay, chemical reaction already occurring at a particular speed. Over a chemical reaction mein or particular speed la poikittu irukum, normal la poikittu irukum. If you add a catalyst mean just increase the speed, increase the rate of the reaction, increase pannu. Clear? So first point that is a mass remains constant, only very small quantity is enough. Catalyst does not initiate the chemical reaction because already all the chemical reactions are occur at a particular rate. Then catalyst does not alter the position of equilibrium at a reversible direction. All the catalyst in generally specific in its action. These are the some characteristics of catalyst. Then types of catalytic reactions. First one is homogeneous catalytic reactions. What is homogeneous? What does mean homo? Same. So homogeneous catalytic reactions mean here involving that a reactant molecule, product and a catalyst, everything same phase. Maybe solid or liquid or gas, whatever phase, but all the reactant, product and catalyst must be same phase. That means example of homogeneous catalytic reaction. Some examples given here. Homogeneous catalytic reaction. Homogeneous reaction. Okay. Sulfur dioxide oxidizes, it gives sulfur trioxide. SO2 plus O2, it gives SO3. Here, what is a catalyst? Nitric oxide. Nitric oxide. Did everything which phase? Gas. So sulfur dioxide undergoes oxidation reaction. Sulfur dioxide oxidize, it gives sulfur trioxide in the presence of nitric oxide. Here the reactant, both reactant as well as catalyst and product all are same phase. Which phase? Gas phase. So that this is example of homogeneous catalytic reaction. Clear? Another one is ester hydrolysis reaction. Methyl acetate undergoes hydrolysis reaction in the presence of acid medium, it gives acetic acid. Here all the reactant and the catalyst and the product everything in the liquid state. Everything liquid state. So this is another example of which reaction? Homogeneous equilibrium, homogeneous catalytic reaction. Homogeneous catalytic reaction. Okay, another reaction, ester hydrolysis reaction. That means what? CH3 COO CH3 methyl acetate. Hydrolysis means addition of water in the presence of acid. Now, okay, one H from here, so it will become acetic acid. Addition of water means, listen ma, HOH. Okay, so it will become acetic acid, remaining ethyl alcohol. So CH3COOH plus CH3OH. Okay, here this is known as ester, methyl acetate. This is liquid in state. Water, you know very well, liquid in state. Acetic acid liquid. Then methanol also liquid state. HCl also liquid. So in this reaction, reactor molecules, product, catalyst, everything in the same phase like liquid state, so that this is example of homogeneous